Okay, in this video, we're just going to go through a pretty standard subnetting question that may appear on your exam. So the question that is down here in blue. We've been given this IP address 209.100.50.0, and we need to break it up into 5 subnets. So for this video to be useful, you're going to need to understand binary to decimal conversions. You're going to need to understand default subnet masks, default classes. You need to understand IP addresses, and you're going to need to understand what a broadcast address is and what a network address is. So some of them concepts will come up quite regularly, and they may help you sort of finalize that knowledge that you may be querying. So what we've got here in this sort of spreadsheet is the last 2 octets. So because we're dealing with a class C network, the 209.100.50.0 is a class C, we're not really worried at this stage in this sort of standard question of the first 2 octets. So what that means is we're only dealing with the 50 and the 0 on this spreadsheet. So each octet in an IP version 4, we've got four octets in this IP address, or equivalent of 32 bits or 4 bytes. So like I say, we're just going to be looking at the last 2 octets. Now you may want to, or you may see other videos explaining it where they've got the first and the second octet as well. I can't fit them all on the screen with what I want to do here, but if you want to understand it further, or you're struggling from this content, then you may want to look up some of them other videos. So we'll start by going through the questions here on the left, and then we'll look at filling in the address range and broadcast addresses. So in terms of questions on an exam, this exam might fit into 4 or 5 questions and come at from different angles. So it might ask for the default subnet mask for this IP address. So the default subnet mask is 255.255.0. So what that essentially is telling us is that all the numbers that are full, or the binary digits that are full, so in this case we'd have 24 bits to equal 255.255.255, they are all network addresses, and the zeros are hosts. So if we saw this in binary form, we'd have 24 ones and 8 zeros. Okay, but that's not good enough for this scenario because we don't have enough subnets. The question is asking us to break up this IP address into 5 subnets. So by default, that considered notation would be /24. So that's representing 24 bits being used for the subnet. So what we want to do is we want to, like the question saying, break this up. So essentially, what we need to understand is that host bits run from right to left. So the amount of hosts is increasing from right to left as we go through an IP address, and subnets are working from left to right, or network addresses are working from left to right. So by standard, the class A addresses have a lot more hosts because they've got more bits available on the host portion, and the class C addresses have more network addresses because they have more bits filled in the network portion. So in this scenario, we'll start with a question. We need 5 subnets. So we're dealing with a 4th octet because it's a class C. So I can't only just use the first, the 2. I can't use the 4 because that's not enough. So I'm going to have to go to 8 subnets. So I'm essentially here, I'm borrowing 3 bits. So if I just turn this a different color, now in a perfect world, I'll be able to draw a line straight down the middle here, and that line would represent, to the left of the line is network addresses, and the right of the line is available for hosts. So our network addresses, or host addresses now, will be available and going up in the number 32s. So there's only going to be, before we go into a bit more detail, there's only going to be 32 available addresses on each subnet. That's what that's saying to us. So to answer this question of what our new subnet mask is, We already know that the bits in the third octet are full, so I need to add the bits that I've borrowed now, or the binary digits that I've turned on, which would be the 128 plus 64 plus 32. So these three numbers here, I need to add up to form our new subnet mask. Okay, so if I add them numbers up together, I get 255.255.224. Okay, so again, we know that we've used 24 bits in the default, but we've added 3 more. So our new cider notation is going to be /27 because I'm using 3 extra bits. Okay, so the total number of subnets I have, because I can't just have 5, I've got to have 8 because 5's not available. So I have 8 available subnets, and the total number of hosts would be 2 to the power of 5. So 32. The usable host is 30. That's per subnet. Okay, so we need to reserve 1 for the network address and 1 for the broadcast address. So the broadcast address is always the last number in that range, and the network address is always the first one. Okay, so let's get into completing this this table here. So the different subnets. So we know our first one because that's been given to us. First network address is 100.50.0. Now, sometimes it's easier to fill in the broadcast address first and work back. So the broadcast address will be the last available IP address in that subnet, because we're going up in 32s. So the range or usable addresses, so this is where devices are connecting to the network, would be -1, and the last one would be .30. Okay, so if people come in with the mobile devices and they're connecting to this subnet, their range, their only usable ranges is between 1 and 30. Okay, so our next subnet address is .32. And like I say, in an exam scenario, it may be better to do this in a simple form like this. Uh, 96, and then 128. Okay, and then again work back from there with the broadcast addresses. So you want this one to be 63. So it's the last one in each address, and this would be 95. Oops. This one to be 127. This one would be 59, I believe. Okay, and then we just fill in the usable ones in the middle bit. The reason why we do this in sort of an industry scenario is to break up different departments. Could be one, different devices. There's many reasons. It's a cost-saving activity because you don't need to purchase new IP addresses. So it is quite important that if you get into networking that you get this area right, because it can save a lot of money in the long run. You don't want to redo it if you get your numbers wrong. Okay, so that's our 5 subnets. Now this would carry on because 5 wasn't an option, and we have had to use 8. So in theory we would have a subnet of 6, 7, and 8. But for this example, I'm not going to go into that. So these final questions here are asking what's the third subnet range. So the third subnet range of usable hosts is here, 65294. So if we put that in there and answer the question. Um, 94. Okay, now the next one is it's asking what's the last usable host on the 4th subnet. So the last usable host is this .126. So a lot of people get confused here and they start adding the broadcast address as a usable host. So the broadcast is not a usable host by a device. So you always need to, if you're looking at subnets, is subtract 2. So subtract, if you've got your range of 32, so hosts available 32, then you always subtract 2, so it's 30. So because one's reserved for the network and one's reserved for the broadcast. So our last usable host on the 4th subnet is .126. And then the broadcast address on the 2nd subnet is here, .63. So it's the last address before you hit the following subnet. So 150.63. Okay, so that, like I say, that should cover quite a bit of topics within your exam from the subnetting side. Hopefully it's made sense. Like I say, if you've not got the fundamental knowledge, it may seem very daunting going over this information. So maybe backtrack through them contents before you hit this, or lose patience with it, because it's not something you can sort of learn quickly. It's something that comes over time with practice. Okay.